So anyhow, if you take a close look, you will see that flat sawn curvature in the growth ring. And if I put a straight object like this ruler here on this face, you will see just how round that is. Now, if you take a look, you'll see that the pivot point of my ruler is not actually in the middle of the board. It's over to this side here. And that is because this pivot point is actually in line with where the middle of the tree would have been. In other words, this wood doesn't include the pith of the tree, but the middle of the tree would have been somewhere around up here as opposed to in the middle of the board. And it always bulges out the most where the growth ring curvature is the most severe. Now in this example, I have a piece of rift sawn European steamed beech. I can see the pattern over here on my side as well. Basically it's a little more flat sawn here, but then comes around like this into more of a rift sawn pattern on this side. So this is the rift sawn area, so I'd expect this edge to be quite a bit off of 90 degrees. So let's take a look at that. You can see how my ruler is sitting remarkably flat on the top face, but the edge has quite an angle to it, opposite the growth rings, and I can show you just how far off 90 degrees it is. Now here I have a piece of quarter sawn oak that has the growth rings running basically this way. Now we're closer to the center of the tree up in here. So this is the edge that might have just a slight bulge. I'm not that close to the center of the tree, so it isn't the starkest example of this, but down here in this area of the edge, if we take a look with this ruler, there's definitely a convex shape to that edge. Now, more importantly, though, we have this crack. You can see a crack here, another one here, and a long one here where the wood has just gotten torn apart. So that part is not usable. We have to rip that off, and we can just use the rest of the wood a little further away from the center of the tree. Now we're going to take a look at this dining room table design, which I had talked about earlier on the easel, where I had mentioned that the boards run across the width of the table because this design has two leaves, and that means that there is no wood movement in the width of this tabletop. That would be longitudinal movement. But in the other direction, this table is 96 inches long and there's a huge amount of movement. So we need to study how we can attach this tabletop to the base and still allow it to move that very large amount, which you might remember was close to 3/4 of an inch year-round. Now there's a lot of complexity under this table that I can talk about, but I'd like to focus in on everything that has to do with wood movement issues. You'll remember that this tabletop is expanding and contracting along the length of the table, which is this way, because the wood moves across its width, not its length. So over here on the end apron, the cleats are moving in and out of the groove, not sideways. So if you take a look here, you see the groove cut onto the inside face of the apron, and you see the cleat there in the apron, but not all the way. Now the cleat is in a fair bit of the way right now because it has been quite humid lately, and it's not quite the season where we would be running air conditioning a lot. So it's at a pretty good amount of expansion. Not all the way though. It's designed not to ever bottom out. Okay, now over on this side, these cleats are only going to move sideways as the top expands and contracts. So you'll see the groove here on the inside of the apron, and you'll see that the cleats are in all the way. I just put them in all the way when I built it because they just move sideways.